see my screen? You see the first question, number 4? Do you
Yep.
see that?
Yeah.
Okay. So we're using the method of substitution for this problem. It goes back to the idea that if I asked you what is the integral of e to the u du, you are supposed to know that this is e to the u plus c. So if we could make this thing right here an e to the u, then you're okay because you know how to do that. So that's why and if you know this kind of aside here, you would just start up by saying, okay, u equals x over 4 or 1/4 x, and then you take a derivative of both sides. The derivative of the left is du. The derivative of the right is 1/4 dx, or dx over 4, and then you solve for dx here. So dx equals, when you multiply both sides by 4, you clear this 1/4, 4 times du. So you go back to your integral, and you kind of got to look at it up here at the top and say, okay, I don't have anything for e, but x to the 4, well, that's u.
Yeah.
Okay, and dx, I have something for that. So your dx is 4 du, and then you just rewrite it here a little bit better here. 4 e to the u du. And then, as I mentioned, kind of over here off to the right, you know that e to the u du is e to the u plus c, this integral. But you have a 4 in front, so that 4 can actually come out, 4 to the integral e to the u du. So your answer is 4 times e to the u plus c. Not sure how much you've gotten into constants of integration, but you don't have to multiply the constants by numbers. They would become new constants. So the final answer is 4 e to the u plus c. But then you have to back substitute. So whenever you substitute up here at the top, you have to back substitute again. U is equal to x over 4 e to the x over 4 plus c.
Okay.
We will do more of these, but that is I see that you actually sent 3 earlier, so we'll do 3 next.
Okay.
Because it'll be very much related. All right, so number 3. The problem does help that it says, use substitution. It tells you what to do. That's often, very helpful here. But you have to know, well, what do I substitute for? And generally it's things like exponents. It's under the root. Kind of maybe if you see something in parentheses, those are kind of ways of knowing, well, what do I substitute for? So
Okay.
as you do more of these, and since your exams are like these questions, you'll know, okay, I need to substitute for these things. So you have u equals minus 3x plus 4, and you need to take a derivative of both sides. So on the left side, it's du.
So it's -3.
Negative 3 dx on the right. And then
Okay.
you always solve for dx, which that's not really correct mathematically, but it's like mechanically what to do. It helps you as a student. So dx equals du over -3.
Okay.
All right, and okay, so now you go back to the original, and when I say original, I mean this integral 4.4 e to the minus 3x plus 4 dx, and you substitute in for what you know. So you don't know anything for 4.4, so you leave that. E, you don't know anything for that, but this exponent here, that's your u, and you always solve for this dx, so it's du over -3, like that. So that's just a substitution step for what we found. So you can do a little bit to reorganize this. So it's the integral 4.4 over -3 e to the u du. I know there would be a desire to okay, let me make this into something else, but it can simply be left as that. You can in fact even bring it outside if you want, because the only thing you care about is getting it into something that e to the u du. The integral of that is e to the u plus c.
Okay.
So you have 4.4 over -3 integral e to the u du. So just this part, that part is what becomes e to the u plus c, but then you're multiplying it all by 4.4 over -3. And as your answer showed, you can actually leave it in that sort of unsimplified form, but you have to back substitute. This is very important because it's easy to not remember to do this because you've gone down all these steps and you're like, wait, what was my u again? So you gotta make sure that you realize it's in terms of x, not u. So u is equal to minus 3x plus 4 plus c.
Okay.
All right. 3, 4. Looks like we got maybe 6 could be good to do next. 6 is not an integral with a u substitution. Let me see if 7 is. Yeah, let's do 7 next, and then we'll see, because it's another substitution problem. We've done a couple now, and I think it's good to keep seeing these.
Okay.
I know you like to see all the steps, so I'm trying to do that as best I can here.
Yeah, I know. I understand like the steps. I think my like weakest point is when I first look at the problem initially, I get kind of like almost overwhelmed because I don't know where to start. But if I can see it broken down in parts, then I know the steps pretty well.
Well, I'll keep trying to emphasize the steps here. These are all substitution problems we worked on so far. I mentioned in the previous problem, often the substitution is like what's in the root.
Okay.
What's in the exponent. These are like good guides for that. So we're just gonna go off of
du negative x squared plus 8.
Yes. So du, and you got to get this right, is minus 2x dx. And you're mixing derivatives and integrals, so it's very easy to forget. Am I adding one, subtracting one? Just that's something to very much keep in mind. So then dx this time is du over -2x.
All right.
Okay. So if we go back to the original here, okay, you look at it and you say, well, what do I have? What can I substitute in for? Well, you don't have anything for 9x, so you got to bring that down. But you have something for under the root, that's u, okay? And then you have this dx is du over -2x, okay? Now, if your instructor didn't say this, you can only have u's when you're done. Okay. Meaning the x's must cancel.
Yeah. So
that's another way to determine if you've done this correctly. Like, do the x's cancel or are they gone? So if I rewrite this slightly, where I put the minus 2x under the 9x, okay, the x's cancel. So we can bring this -9/2 out in front. Okay.
Oh, wait, and then get -9/2. Oh.
These cancel, the x's cancel. Okay. And then the square root of u is really u to the 1/2 power. Sometimes it's good to write it that way. Okay, so the x's cancel, you bring the -9/2 out in front, and the square root of u is u to the 1/2. Okay, so now we're going to take the integral of this part. This is the part we're taking the integral, not this number out in front, just this. So this is power rule. Power rule for integrals says the integral of x to the n is equal to x to the n plus 1 over n plus 1. So you have to add 1 to the 1/2. So it's u to the 1/2 plus 1 over 1/2 plus 1. And then this -9/2 comes down. And then you have this plus c.
Okay.
Okay, so this is -9/2 u to the 3/2 over 3/2 power. So generally these numbers plus c, these numbers here, these generally match.
Yeah.
Okay. But again, like that, maybe the final answer won't look like that, but you actually can put it into WebAssign this messy, but it's if you have to simplify it, there's a little bit to do here. So this minus 9 halves is multiplying. So what a lot of students do is they will flip the 3 halves. So like 1 over 3 halves is equal to 2/3. So you're moving this 3 halves out in front. So it's minus 9 halves times 2/3 because you're flipping the bottom, u to the 3 halves plus c. And you can see that you'll cancel out some fractions here. So this becomes, these cancel, minus 9 over 3 becomes minus 3, u to the 3 halves power plus c. And then recall that u is equal to minus x squared plus 8. So you have to back substitute in here. So it's minus 3 parentheses minus x squared plus 8 to 3 halves power plus c.
Okay.
There is a lot that went into that. If any of that was unclear,
No, that made sense.
great. Okay, so let's do 3, because not 3, 4, what was it, 6. Let's do 6 because it's a power rule problem, so it's kind of like the one we just did. There's no substitutions, but it is a power rule integral, and there's really only the one exception. So there's so the power rule integral, this is the one, one of those you have to know. The integral of x to the n is x to the n plus 1 over n plus 1. And it works for everything except when n equals -1. So it doesn't work for that one, because the integral of x to the -1 power is the same as the integral of 1 over x. And hopefully in class you saw that that becomes the natural value of the absolute value of x. That's the only exception here.
Okay.
Okay, so we're gonna do this one. We're gonna break this one apart, but we're gonna use this information off to the side. So you can actually break this up into 2 integrals. It's the integral of 5u squared du minus the integral of u to the -1 du. So I'm just kind of distributing that du to both. It's not exactly what's happening, but that's mechanically what's happening. You can bring this 5 out in front, so this becomes 5 integral u squared du minus integral u to the -1 du. So the power rule, again, the power rule here for this first one, you take that exponent and you add 1 to it. And then you divide by the new exponent, which is the same thing. And this 5 obviously has to come down here. Minus, now this is the exception, because if you add 1 to -1, you get 0. And you don't need to know why, but you need to know you need to know what to do here. And the what to do is to recognize that this is the exception, that this becomes the natural log of the absolute value of u. Okay, now there's only one constant of integration, so you only have to write one of these. Okay, and then on the left here, it's up to you how much you simplify. 2 plus 1 is 3. That's on the bottom, so it's 5/3. U to the 3rd minus the natural log of the absolute value of u plus c.
When you say there's only one c, like I've only seen one c. So is there a case where there would be 2?
No, but what I was trying to refer to here is, like, let's say you have the integral of x plus the integral of x squared. And you could write the first one, it's 1/2 x squared plus c1 plus 1/3 x cubed plus c2. But see, these two are just constants, and you can say, well, c1 plus c2 equals c. So it's 1/2 x squared plus 1/3 x cubed plus c. I probably overly complicated. I just wanted to emphasize you only ever have one c.
Okay.
There's no exceptions to that. Nothing to look out for.
Okay.
All right, so let's do 8 next. Yeah, we'll do 8 next. And all right, evaluate the integral. Okay, so there's a lot. Like, to me, there's really 3 separate problems here. There's this one I've circled, this one, and then this one. And as a new calculus student, you definitely want to write them out that way.
Oh, sorry. That's actually Emma calling.
Well, if you need to take it, it's this is your time, so totally up to you how you use it.
No, it's okay.
All right. So the next thing here is we've broken this up into three separate integrals. Okay. For this first one, the way you want to visualize it is okay. This 6.8 can come out in front, and then this is 1 over x to the 0.5 power. But you generally want to write it as x to a power. So if I write negative 0.5, that's how this 0.5 goes up to the top.
Okay.
And it's usually good as a new calculus student to write it this way. Because then you're just using power rule. You're just adding 1, dividing by the new exponent, and so on. This middle one, it kind of looks related because there's a 0.5 up top. The number out in front, though, is really this 1/6. So it's 1/6 integral x to the 0.5 dx. And then this last one here, this 8 can come out in front, so it's -8 integral e to the x dx. So let me just rewrite these down here. 1/6 integral x to the 0.5 dx -8 integral e to the x dx.
Okay.
Okay, so now for the first one here, this is a power rule. So you're gonna add 1 to the exponent, and you're gonna divide by the new exponent. So you just write it again. That 6.8 is out in front. The second one here, same thing. You're gonna add 1 to the exponent, divide by the new exponent. And for the last one here, do you remember what we did for e to the x or e to the u?
Is it just e to the x?
It's just e to the x, and then there's only ever 1 plus c.
Okay.
All right. Okay, now there's some simplifying to do here. Like in the first one, oops, sorry, I went too far there. First one, it's x to the 0.5 power over 0.5, and then you got a 6.8 here. WebAssign will accept this. Your teacher may not, if you're doing this in person. X to the 1.5 power over 1.5 minus 8 e to the x plus c. So it's just a matter of like how much of this do you need to simplify? And that I can't tell you, but WebAssign will accept these numbers that
Yeah,
you've
that's
got
fine.
here,
That's good.
which is nice because I think we had some problems or issues with that in a previous lesson where you said, didn't take it. You had to simplify the answer. All right, that's 8. Let's do 9 next. 9 is a use substitution. All of the ones that are use substitution have said as much. If you were taking a non-business calculus class, they wouldn't necessarily tell you what to do, but this one says substitution. So I mentioned before, sometimes it's what's in parentheses, and that is the case here. Your use substitution is 1 plus x cubed. Your du is 3x squared dx. You want to solve for dx, so your dx equals du over 3x squared. So we're going to write the original, the integral x squared over 1 plus x cubed to the 1.3 power dx. And you rewrite it, but you only substitute for what you know. Like all you know is that, okay, 1 plus x cubed, well, that's u. So you know that that's u to the 1.3 power. You don't have anything for x squared, so you need to write it for now. You hope it cancels. Dx is du over 3x squared. Well, looks like you've got a cancellation. The x squareds, they cancel. Okay, so you're left with the integral. This 3 is on the bottom. There's really a 1 there, 1/3. This is 1/3 times 1 over u to the 1.3 du.
wait, so the x squareds cancel. 1/3, you're taking that from, oh, okay. And then times 1 over,
Yep.
okay.
This has to stay on the bottom. The one u to the 1/3. But yeah, but there's a lot that goes into this, but there's not much to write because things are canceling, you're moving things.
Okay.
But you've got to be comfortable doing that because the next step here is very important. So 1 over u to the 1.3 is equal to u to the minus 1.3. If you move something from the bottom to the top, you negate it. And the reason you do that, it's just easier to work with integrals when you have an exponent, not a 1 over something to an exponent.
Okay.
Because the power rule here says, take that 1.3 and add 1 to it, negative 1.3. Your new bottom is negative 1.3 plus 1 plus c. All right, now we write 1/3 u to the minus 0.3 power over negative 0.3 plus c, and your u, if you recall, was the 1 plus x cubed. So you're going to substitute that back in. You're going
Where
to
did the du end up going?
say that one more time.
Where did the du, like if you go up, it says du, where did
Yeah,
that go?
the du goes with the integral. So whenever you have an integrand, the symbol right here, you have to write a du.
Okay.
When you perform this step, the du goes away.
Okay.
All right, so let me scroll down and carry out this last step, this back substitution step. 1 plus x cubed to the minus 0.3 over minus 0.3 plus c. Nine.
Okay.
Okay, so I'm gonna go to 11 next. Is that?
Yeah, that's fine.
All right, the marginal cost of producing the X box of CDs is given by this function. The total cost to produce 2 boxes is 1,200. Okay. By now you should know that marginal cost means the derivative. That's what they're giving you. It's this 11 minus x over x squared plus 1 squared. That's your marginal cost. And hopefully in class, the instructor indicated that if you integrate marginal cost, you get cost.
Yeah.
Okay, so in short, we need to integrate this function. So this is no different than what we've been doing, except it's put in context of a business problem, I guess. So first thing I would tell you to do is you're going to break this apart. It's integral of 11 dx minus the integral x over x squared plus 1 squared dx. The first one we actually haven't covered yet. There's no variable here. I think this may be confusing because if there is no variable, you do include a letter. This becomes 11x.
Okay.
And it's almost easier to explain, like if you go backwards, what's the derivative of 11x? Well, it's 11. Okay.
Yeah.
All right. Now the one on the right is a u substitution. What is the u substitution looking at this? Could you tell me?
So it's x squared plus 1, and
Good.
then du is 2x, and then dx is 1/2 du.
So du over 2x, yeah. So we substitute in for what we know. So we know that the thing in parentheses is u, And we know that this is du over 2x. So this is the step that was unclear in the last problem. So let's make sure it's clear here. X and x cancel.
Yeah. Okay.
There's a 1 over 2 here, so that's 1/2. This u squared has to remain on the bottom.
Okay.
Now I'm going to bring the 1/2 out because that's allowed. Okay, but the 1 over u squared becomes u to the minus 2. So this is u to the minus 2 du. So now we're going to take the integral of this. So you add 1, and then you add 1, and this minus 1/2 stays with it.
Wait, where? I'm trying to see like the du 1/2 times. Oh, okay. I get
When you
it's like the du like gets brought down to the other side of it.
it gets, yeah, the du gets consumed with this integral symbol. Like once you do the calculus step, it gets consumed and you don't need it anymore. Above though, dx is replaced by du over 2x.
Okay.
There are simpler examples that we could go through that would really make that clear, but your homework just jumps kind of into medium difficulty questions. But let me know if you want us to go just kind of emphasize that.
That's okay. I can rewatch this too.
Okay. So the next step here is to simplify minus 1/2 u to the minus 1 over minus 1 plus c. And that simplifies to, so that this negative 1 goes with this negative out in front. It goes 11x plus 1/2. U, if you recall, was x squared plus 1. So it becomes x squared plus 1 to the minus 1 power plus c. And this is your cost function. This whole thing is your cost function. Your cost function is 11x plus 1/2. This right here we can write as 1 over x squared plus 1 plus c. Okay, but we're not done, but that's how you find the cost function.
Wait, how did it turn into a plus? 11x plus 1/2.
This minus 1 right here goes with this negative there.
Okay. And they're multiplied.
Yes.
Okay.
So if we go back up to the question, it says the total cost to produce 2 boxes is 1,200. So if x equals 2, the cost equals 1,200. That's all the way up here at the original part of the equation. The total cost to produce 2 boxes is 1,200.
Okay.
This is referred to as an initial condition, or it's a point that allows you to figure out what C is. You use this information to find C.
Okay. Okay. So you just plug that in.
Yes, 11 times 2 plus 1/2 times 1 over 2 squared plus 1 plus C, and you solve for C. And you're just moving things around. Like this is 22. This is this is 1/5. At times 2, that's 1/10. So it's $22.10. And then you subtract it from 1,200. So all of this combines that number there. You might check that, but it looks like you get like 1179.90 equals C. And then you take that and you return it back to this line right here. So the cost function of x is 11x plus 1/2, 1 over x squared plus 1 plus 1179.90.
Okay.
Whenever you find the value of C, it adds an extra step to to these problems, and it just adds more stuff to it. Looking to see if there's another one. It'd be really nice to do another one like that.
Could you actually do, there's 13 and 14 are two problems on my homework due Monday that I haven't done yet.
Sure.
So,
All right.
and do you only tutor Monday through Friday?
No, I'm available on Sunday, Sunday through Thursday, and then you can always text me and just ask me for something if you need a time that isn't there. I don't do it for customers that I haven't worked with before, but I'm usually willing to work around for existing customer
Okay.
like yourself. So um, but my preference is Sunday through Thursday. So if you have a day other than that or time that isn't available on the website, just let me know and I'll add it or fill you in.
Okay.
Okay, there's a lot of words here. Okay, and because you're in this section where you're integrating, you have to know that you are integrating this function 1.1 t squared minus 2.6 t plus 2.3 dt. And then there's what are called limits of integration. Hopefully that was covered in class. So this is your lower limit, and this is your upper limit.
Okay. So do you integrate each term like separately?
Yeah, now, I mean, okay, so there's a couple of ways to do this. I think the answer here is, does it say to round?
Just estimate to the nearest million.
Yeah, okay. So this is important because there's some steps here you show by hand, but then you do it in your calculator just to some degree. So I know we've been breaking each one of these up, but at some point you don't want to do that. You want to say, okay, I understand how to do this.
Okay.
So it's 1.1 t, and then you add one to this. So it's t cubed over 3. See how I added 1 to 2 and put the new one on the bottom here?
Yep.
Minus 2.6. This is t to the 1, so it becomes t squared over 2 plus 2.3. There is no t, so you put a t there.
Okay.
And then you evaluate it from 0 to 9. I don't know if you've seen this symbol before this, but this means evaluate at the upper and then the lower limit.
Okay. So then you just plug in 9 and 0.
Exactly. So it becomes 9 cubed minus 2.6, 9 squared plus 2.3 times 9 minus, and you have to evaluate it at the lower limit. But what happens when you put 0 in for t in each of these?
Just 0.
0. So some instructors want you to write out it's minus 0 for that. And that's why I say you're going to grab your calculator and you're going to get a number for this.
Okay.
So I end up getting 182.7, but it says to round to the nearest million. And since it's in millions, I'm going to guess it's 183.
Okay, that's what I got too. Let me check.
Go ahead and check that if you haven't done that already, and let me know if we need to.
Oh yeah, it says it's wrong. Maybe it's 182.7. Nope, that's wrong too. Hmm.
1 over minus 2.6x plus 2.3. Oh, you know what? I see. So I gave you the wrong. So the lower bound here, they're using these years. I didn't catch that. So they're using these years. So the years are 2007. 2005 corresponds to year 0, so 2007 corresponds to year 2, and 2010 corresponds to year 5. So these are not correct. It's 2 to 5.
Okay.
And that changes what we do at both endpoints here. So let me grab that here. So that's 2 to 5. All right, let me rewrite this because it's completely wrong, and then we'll do this also. It's 1.1 over 3 times 5 cubed minus 2.6 over 2 times 5 squared plus 2.3 times 5 minus, and you put this in parentheses. It's the same thing, but it's 2 cubed minus, this is a 5 here, minus 2.6 over 2 times 2 squared plus 2.3 times 2. So go ahead and check that. I'm gonna get the number for us as well. It'll be a little bit smaller. This one says 22.5 million is the final answer. That would round to obviously 23, but if you're down to one guess, you may want to do a similar problem and make sure that it's rounded to one decimal or rounded to the ones place.
23 is right.
Great. Okay, so then you said 14 you want to make sure we get to as well.
Yeah.
All right, let's get to it. All right, so this one's pretty similar. It's asking for it's asking for another integral. Your calculator can do this integration for you, and it'd be good to do it as a check. I can show you that if you'd like.
Yeah.
I know you have to show the work, but it's good to have here. So you're integrating this time. So we're gonna do the limits of integration first. So it says 20 to 22. So those are your limits of integration. And it's this minus 0.028 t cubed plus 2.9 t squared minus 44t plus 95 dt. All right, so it's power rule. So for each of these, you're going to write the coefficient, okay, and then you add 1 to the exponent. So it's 4 over 4. And that's t cubed over 3, t squared over 2, and then the last one doesn't have a t, so you write a t, and you're evaluating it from 20 to 22.
Okay.
So again, like you have to put the top limit in first. You're going to evaluate it at each of these endpoints, 0.028 over 4 times 22 to the power 4 plus 2.9 over 3 times 22 to the power 3 minus 44 over 2 times 22 to the power of 2 plus 95 times the power of 22. And then, this is key here, and then you subtract. I'm gonna copy and paste here. And then you subtract, I don't know where to put that, we'll say subtract all of this, but this time instead of 22, it's 20. So wherever I have a 22, I'm going to replace it with 20. So 20, 20, 20, 20. And then I'm going to give you the final answer, and then I'll show you how to do it with your calculator.
Yeah.
So that you get the right answer. Go ahead.
It's a lot of work.
Yeah, and your calculator will do the integration, and most of the mistakes are made from just entering it wrong. So you
Yeah.
kind of need to show the work
And then
um,
check it.
and then do it in your calculator. Say, okay, I did it. Your instructor kind of has an obligation to show you this because it's a check for you as well. 0.028, 2.9. Okay, so then it says round to the nearest 10 milliliters. So I get 381.941. So the nearest 10 is that position. So it looks like it's 380 is your final answer on that.
380. Okay.
Do you have a TI 8384? What do you have for a calculator?
TI 84.
Okay.
And that worked.
So you're going to go to math on your calculator, math, and then 9.
Okay.
Math 9, and then does it present to you an integral symbol with
Yeah.
some boxes?
Yeah.
All right, so all you're going to do, and you ought to do this for yourself at some point, you can do it now, is put the numbers in, put in the original equation.
C of T.
You want to use x, not t.
Or yeah.
But, and then it'll sometimes it spins a while depending on what you've done. You're going to put that in. Whoa. And then, yeah. And then you should get the same number I got, the 381.941.
And then there's a D box on
You
the
want to
bottom.
put the same variable x again.
Okay. Okay, yeah, I got 381. So
Okay, so if it were me on a test, I might do that first so that I know what I'm supposed to get, and then show the calculations to get there, or make sure that the calculations we did up here actually give you that number, just as a go back and forth check.
okay. Thank you.
Okay, so that's 15, 16. Okay, so the only ones we haven't done, looks like we haven't done 12. So
Okay.
12 or 15 or 16. Do you have a preference on those?
No, we can do any of them.
All right. Let's do 15.
Okay.
All right, your name is Gela. Okay, and you toss a weight upward at 12 feet per second from the top of the Leaning Tower of Pisa, which has a height of 186. Okay. All right, so now it says write the function's velocity as a function of time. So what you have to know to be able to do this, and you wouldn't know this unless someone told you, is that it's v0 plus acceleration times time. This comes from a physics class. This comes from your teacher telling you, or you working with someone like me that tells you. There's no way for you to know this if someone doesn't tell you that. So that's what I have to say, and that means you got to almost have this written down but ahead of time. So they're telling you v0. They're telling you v0 is 12. That's where the 12 comes from. A, though, is known to be minus 32. That's you have to be told that, or someone gives you that information. That's why it becomes 12 minus 32t.
Okay.
Okay. All right, now to do part B, you have to know the following. You have to know that the integral of v of t dt, the integral of this thing, is your position function.
Okay.
So in other words, we need to integrate this 12 minus 32t.
So are we just doing like the n plus 1 or
Yes.
1 plus n? Okay.
Yeah, so in this case, because 12 is just a number, it's 12t.
Yeah.
Minus 32t squared, because you add 1 to the exponent over 2,
Yep.
plus C. So S of t equals this. So a little simplification. You tend to only simplify if you need to find C, which you do here. Okay. And you might be saying, well, how do I know how to find C? They have to give you some sort of point or initial condition, and they do that up here. They tell you that the height.
Wait, how did you get rid of the T on the 12? Like,
Oh, that's just an omission on my part. It's supposed to be there.
okay, so penalty was okay.
All right. So it tells you that the height is let's see, the height is 186. They tell you that when t equals 0, because they're starting at the top, S of t equals 186. So this is a very straightforward one, but you're plugging these values in: 12 times 0 minus 16 times 0 squared plus C. So 186 equals 0 minus 0 plus C. 186 equals C. And you put that back into this original equation. You rewrite it down here. S of t equals 12t minus 16t squared plus 186.
Okay. And that's the answer.
That's the answer to part B. And then it asks, where will it reach its zenith or zenith? I don't know how that's pronounced, but it's saying where will it reach its max height? And you know that this is a parabola. It goes up and then it comes down. Boom. Okay, hits the ground there. So it's asking what's this position and what's this position. And there's many ways to do this. You could obviously graph it. If you had access to a graphing calculator, you can also use formulas, which is what we're going to do. If you went back to your pre-calculus class, your college algebra class, this is a quadratic. Your quadratic is S of t equals, I'm just going to rewrite it, minus 16t squared plus 12t plus 186. And this is in this form: ax squared plus bx plus c. A equals minus 16, b equals 12, and the place where it reaches its max height is minus b over 2a. So that's minus 12 over 2 times minus 16. And we can see that that ends up being 0.375. Okay, and then to find the height, you take that value, you put it back in. You go S of 0.375. That equals minus 16 times 0.375 squared plus 12 times 0.375 plus 186. And that gives you 188.25.
So the point would be 0.375 comma 188.25.
Yeah.
And that's the height.
Yep.
Okay.
All right. Well, this takes us to the end of our lesson today, and I'll send you the notes and the screen recording out shortly. Thanks again for scheduling. I'll see you next time.
Perfect. Thank you.
You're welcome. Bye now.